All right, we're going to switch gears for a second and start looking at another way to talk about our functions, right? Instead of the algebraic function, we're looking at a graphical representation. And for these cases, just like in the previous ones, you really want to pay attention to whether we're talking or been given the original function or the first derivative already. So in example 6, we're looking at the graph of f prime of x. So this is already our first derivative. And we want to find the intervals where f is increasing or decreasing. So we're not being asked about f prime, we're being asked about the original graph f. So we know this happens, increasing is when our first derivative is greater than or equal to 0, and decreasing is when our first derivative is less than or equal to 0. Now, we cannot let ourselves get excited by the fact that I can see intervals of decreasing and increasing on my f prime graph, because that's not what I've been asked for, right? I want to know when my f prime graph is positive or negative, not when it's increasing or decreasing. We'll get there eventually, right? But for now, this is what we want. So we can do the same thing, we did before. Our critical values were when our function, our first derivative was either 0 or undefined. So we can look at this and say, oh, here is 0, here it's 0, and here it's 0. So we have 3 critical values on this graph. We have -4, -1, and 1. Boom. That's like steps 1 and 2 right there. Maybe even 3. I don't remember what the numbers are. And now we just need to figure out if our f prime is positive or negative, and that is all about where it is on the graph. Positive is above the x-axis, boom. Negative is below the x-axis. This is why we're doing so many of those sketches of the functions as we're doing these tables, is so that we are fluid and able to move back and forth. So here we are positive, positive. We have one little negative section, and then we have a positive section looking at our graph. So you don't even need to make the table if you have the graph. I'm just sort of showing you these two versions so you can see how these are related to one another. So we want to write down our intervals of increasing. We are increasing. And again, this is when it gets nice because there is that bounce. If we're using the definition of greater than or equal to 0, then we get to write down negative infinity up until -1, include, right? So, as much as you may hate it, it does save you some work. And then also from 1 to infinity, right? Alternatively, we might be looking at something like this, which is just more writing. So, I mean, if you don't agree with the folks who think that it includes, then you can do that instead. All right, and decreasing is from, I almost changed it up, -1 to 1. Boom. Or again, I don't like how that one looks. It's very short. You could have used your parentheses if you are an open interval fan. So there you go. That's our intervals of increasing, decreasing from a graph of our first derivative.